Welcome to the first lesson, Module 1, Lesson 1 for our class this year. Things might change or adapt a little bit according to how we're seeing things are working, not working, and we'll adjust as we go. But we'll go ahead and jump straight into it. So for our today's lesson, the main idea is understanding the terminology equal groups of. So terminology equal groups of are basically saying I have multiple groups and they are all the exact same. So to give you an example of this, for multiplication, let's say I have 2 times 3. So the concept we're trying to get at is that this 2 is telling me how many groups, so this is the groups, how many groups there are, and the 3 here is representing how many are in each group. So typically I write down groups under here and in each group. So visually, what this would look like is, let's say I'm talking about apples or whatnot. So the 2 would be like the baskets. I have one basket here and another basket right here. So I have 2 groups or 2 baskets. Now, the 3 in each group is saying there's 3 apples in each bag or each basket. So what you would do after that is go ahead and put those 3 beautifully drawn apples, put a leaf on it so they actually mildly look like apples, 3 apples. But more specifically, it's saying that there's 2 groups, and in each group, there are 3 apples. So I would do the same thing over here as well. And so the idea here is that we're trying to teach that we have 2 groups and there's 3 in each group, meaning how many total apples do we have? And we just count them up. We go 1, 2, 3, 4, 5, 6. Later on, we'll then go into the idea of skip counting in that, but you could also just go 3, 6. So there's multiple strategies for this. Now, one of the big things, and I'll go into this in later lessons as well, is teaching that 2 times 3 visually is not this. It is not 3 baskets with 2 in each. That's something different. This 2 times 3 does not equal this. It's not that. So I'm going to draw a line depicting that. This down here would be 3 times 2 because I have 3 groups, 1, 2, 3, with 2 in each group. Now, this kind of seems like a bit of a long round way of explaining the concept of what 2 times 3 or 3 times 2 is. But in the long run, we're trying to get across the idea that math, they mean things. They're just not numbers. They have specific meanings behind them. So this could eventually change into I have 2 scholars and each scholar has 3 Skittles. How many Skittles do I have? Or I have 2 pizzas and each pizza has 3 slices. They'll be pretty big pizza slices, but you kind of get the idea and how this can expand into further understanding. Now, there's multiple ways of writing this. So I'm going to go ahead and erase this real quick. Don't remember, we'll hit on the concept of 2 times 3 and 3 times 2, how they're the same, but not, we'll hit on that later. So don't worry too much about it right now. So I'm going to go ahead and erase that off right now. And I'm going to kind of give an idea and a visualization of how we can rewrite problems to look like different things. So in your math books, I have one right here. This is the one you'll be using. I'm actually going to go ahead and I'm going to do the very first problem in your problem set. And in this one, you can kind of see it's got the 3 hands and it says fill in the blanks to make true statements. It's on page 5. So if you want to go ahead and get to there, you're more than welcome to and follow along with this. So I can give you a second or two to get there if you'd like to. All right, and if you need to pause, you can pause. So on that question, it's showing 3 sets of hands. So I'll kind of do the best I can to visualize that up here. So it has 1. Okay, just making sure I'm doing the right number of fingers because that is relevant to the question. So I'm going to go ahead and make another one. So 1, 2, 3, 4, 5, and one last one. 1, 2, 3, 4, 5. So we have 3 hands on this board. Now, on the assignment, it's going to say something along that's 3 groups of 5. And so what's asking is, what does that mean? What does 3 groups of 5 equal. Saying, what does that mean? What is it asking for? And long run, it's saying, I have 3 hands or 3 groups, and in each group there are 5 fingers. So it's asking, in total, how many fingers do I have altogether? And you can add those up, and you can just count up if you'd like. You can just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And or you could skip count it, which we'll start pushing on here in a little bit, going 5, 10, 15. And so for that, you would just write 15 right there. Now the second part of the question is stating another way that we're going to be writing this. And this is important to understand all 3 ways of writing this. And it's 3 5s. Now, I will admit this is probably one of the more confusing ways of writing this, but it's basically saying I have 3 5s. So 1, 2, 3. I have 3 5s. There's 5, or there's 3 5s. It kind of is a little weird, but it's basically just saying 3 times 5 in just a unique way of writing it. The first one will be just the number, and the other one, which is how many are in each group, will be written out. And for that, you just write the same thing, 15. And the very last one is the traditional way of writing, which is a 3 times 5. And you just write 15 for that. And that's one that we'll eventually get to. But we really want to make sure we understand why it equals 15. And that's the main goal that we're going for here, is understanding the why. It's good to know that 2 plus 2 equals 4, but it's better to understand why does 2 plus 2 equal 4. A little bit of a small example, but for this one, it's good to know that 3 times 5 equals 15, but it's better to understand why does it equal 15 other than just, well, I skip counted it. There's a reason why visually why that would be the case. Now, there's one more thing I do want to show before opening it up to you guys so you can go and continue on your work. And it's the idea of what everything in a multiplication sentence means. And once again, I'll most likely hit on this in later lessons as well. But I want to just write out another problem. I use 3 times 5, the one that we just used. I have 3 times 5 equals 15. Now, this is the very important part. In the multiplication, I'm going to say it again, in multiplication, because it changes a little bit in division, this last number right here, after the equal sign, is the total. It's how many in all do I have? It's the in all. So if you have a question that says, what is the total? It's asking that question. It's saying, at the end, what does it equal? Now, these other two have another word for them. And if earlier in this video, I kind of already mentioned them a little bit. This first one, the first number in a multiplication word sentence, sorry, I got my wheel over my cord a little bit, is how many groups there are. So I'm going to write groups under here. And if you would like to, every single time you write out a multiplication problem or practice this at home, I highly recommend doing what I'm doing right now every single time, just to kind of get into the habit of it, understanding what they mean and why we're doing it. Because if you get in the habit to this in a couple of lessons, a couple of zerns, a couple of problem sets later, it's going to make sense in why the questions are asking certain things. And so I'd also underline this 5 and say in each. So in long ways, you can kind of say this in the sentence form. You can say we have 3 groups with 5 in each to equal a total of 15. That's the idea. And just kind of to make sure we understand why I'm going this way, we're going to be teaching the idea that 5 times 3 does equal 15 as well, but this is 5 groups with 3 in each group versus 3 groups with 5 in each group. And we want to show why that's different. Don't need to worry about that too much right now, but that is kind of where we're starting to head to in examples and whatnot. But hopefully this was helpful. Hopefully this short little lesson was enough to maybe answer some questions, answer some concerns, maybe some, I don't understand what's going on with this problem set, because I'll agree 100%. Like there are some things that you might look at this and be like, I don't understand why we're doing this. It just seems like extra work. But I can promise you, I 100% agree with what Eureka is doing. I love the format because it takes scholars, and instead of just memorizing what things are, just memorizing that 3 times 3 equals 9, or 16 divided by 8 is 2, it lets them understand why the math works that way. So when they get into middle school and high school math, things make a little bit more sense on why those formulas work versus just memorizing formula. And if you understand why things happen, you understand the processes that come after them a little smoother as well. A little less of a, well, I don't understand it, but I just know I'm supposed to do this. So it's a little bit more work in the front end, but I'm a firm believer. I really, really like this method, and I really like the strategy. So hopefully this was helpful, and you guys have a good day.